How's it going, everybody? In this video, I wanted to begin diving into the service side of the operations because we've got the transport side pretty much nailed down at this point. So we're going to be focusing on some of the details that go into how things work and what you need to know from an operations perspective of what's going on. Because for those of you that come from a traditional routing background, and you haven't transitioned into VRF aware specific routing, and let's say for example you've got your CCNA and you're working on your CCNP, or you've had a CCNP for a while and you're transitioning to CCIE. One of the big things that I struggled with when I was studying for my CCIE was the VRF aware component of all the routing protocols, and that's one of the things that SD-WAN here leverages pretty heavily is VRFs. So I'm going to be taking a kind of a deeper look at how that works and to try to help you understand how that comes into play to provide the traffic separation. So if you don't understand that concept, it's going to be kind of important that you do, because as you proceed forward, there's going to be some outputs that you're going to be seeing that are going to require you to have a back-end knowledge of what's going on. I'm going to try to help paint that picture, but if you might need to go back to something like DMVPN, which this solution is very similar to DMVPN Phase 3. With it out of the gate, once you have all the V edges online and everybody's happy, you will have a very much a DMVPN Phase 3, a VRF aware DMVPN Phase 3 specifically solution at hand, minus having to spend a ton of time creating VRFs and GRE tunnels and DMVPN and IPsec and crypto. Something that could take someone even at my level a couple of hours to set up. I spent probably an hour and a half building the lab and I'm done. Like, I didn't have to do anything crazy. It was just a matter of onboarding some stuff. So we'll take a look at those details and how that works. So one of the key things, let me do a little bit of whiteboarding here to try to help paint the picture. But excuse me. So one of the main things that I found when I started diving into the solution was not necessarily the complexity, but what it was that the SD-WAN solution was trying to solve, right? So the reason why I bring this up now and not earlier or not later is because we're kind of at that transition point between, okay, we've gotten the controllers up and running, all that's good. We've got some V edges working, all that's good. Got all that good to go. And then we've got connectivity from a control plane perspective and a management plane perspective back to our controllers. All that's looking really good. And then on top of that, we have a bunch of IPsec VPNs that are set up between all the devices, right? Everything's looking good there. So I'm drawing a bunch of lines in here just to help you understand operationally what's going on. So we've got this connection here, we got this connection here. Actually, that one doesn't set up right there. But we have all these connections going back and forth, right? So this is where we're currently at. So now, since we have the transport set up over both internet and MPLS, now we need to talk about how do we take advantage of those connections that are providing us the connectivity between the V edges, and how do we take the routes sitting behind the V edges, and how do we distribute them? So let's take a look at that. So the way that VipTele does things is much like how DMVPN Phase 3 does. So DMVPN Phase 3 is much the same way. So specifically VRF aware DMVPN Phase 3. Now the idea with DMVPN aware, VRF aware DMVPN Phase 3, what that really means is the interfaces that are facing the internet, so these interfaces right here, 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 and here, they're in a VRF. So they're in their own local routing table, and that routing table is WAN facing. So that basically means that from the inside, so this would be a regular routing, this would be a user-specific routing table. Maybe you create the VRF WAN, for example, or whatever other term you want to use, right? You use VRF WAN, and then you place the interfaces that are going to be facing the WAN inside of that VRF, and then you do your VRF aware configurations for IPsec and so on and so forth. Now, the idea is that between these connections here, so I'm going to draw a line here, between here and here, for example, all this connectivity here is inside the VRF, right? And that's what VPN 0 is doing. VPN 0 is the WAN, right? It's actually providing the underlay connectivity. It gets you from here to here, right? It's all the underlay. The part that makes SD-WAN shine is the ability to take all of this stuff in here, right? All the internal routing, and be able to advertise that over the top. Let me go to a different site. Over the top to here, right? And let me be specific. When I land, I'm landing over here. I'm not landing inside the VRF. I'm landing inside of what would be the service VPN. Now, the service VPN is going to be any VPNs that are LAN facing, right? So we have users connected to the, say, for example, our router 15 here. You get users plugged in, and then those routes are being propagated to the rest of the network, right? Everything is good to go there. In situations like that, no harm, no foul. But when you run into situations where you need to propagate routes and you're not sure how the VRF comes into play, that becomes a problem, because the service VPN is also a VRF. So for example, in this interface right here, this guy here, gig 0/2, this would be its own VRF. And then if I was to do the same thing here on this interface, this would be another VRF. And this guy right here would be another VRF. You might say, okay, VRFs, well, how is that important? It's traffic separation at layer 3. So instead of you going in and taking a bunch of interfaces that are in just physically on the box, and then you start giving them IP addresses and places, they're automatically injected into the global routing table or the default VRF. Because they are placed inside of they're created VRFs, right? So user created VRFs. Because they're created, that means that they're not going to be placed in the global routing table, which means they are everything that's going to be landing inside of them is going to be VRF aware, or going to need to be VRF aware. Static routing, multicast, IPsec, BGP, dynamic routing, the whole 9 yards. Everything needs to be VRF aware. SNMP, DHCP, everything. So think of it like you're taking a router, just like you would a switch, and you create a bunch of VLANs on that switch, and then you're carving that up so the switch is logically then segmented. You're doing the exact same thing with the VRF. Okay, I want to make sure that it's abundantly clear. We're going to start off with a single VRF or single VPN, VPN1, and we're going to deploy that everywhere. Now, there's a couple different ways. Let me go ahead and clear the screen off. There's a couple different ways that you can advertise stuff, right? So the connectivity between here and here, for example, actually, let me do it this way. Between here and here, and between here and here, for example. In order for this to work, you use OMP, the Overlay Management Protocol. And what ends up happening is this is the control plane, as we talked about in a previous video. If I was to enable, say for instance, this link right here on vEdge 1, and I was to enable this link here on vEdge 4 inside of VPN 1, as soon as I no-shut the interface and apply an IP address to it, it would, this particular prefix, right, so 10.116.0/24, would automatically get propagated over to here in VPN 1 and show up as a OMP route inside of VPN 1. If you do a show IP route, you would see 1, and then you would see 10.1.16.0/24 via OMP, right? Now, the same thing would happen here. This route right here would get advertised over to this guy, and then you would see in here, you'd see 1, and you would see 10.4.15.0/24 via OMP, right? That's how this works. So when you're creating a VPN, you can have multiple interfaces in the VPN, or you can do on the vEdge cloud devices that we're working with, the ability to do sub-interfaces doesn't seem to work on the vEdges. I haven't been able to figure out why, but they don't seem to work. So because they don't seem to work, I took an alternative path and I just started using other physical interfaces so that I'd be able to provide the traffic separation. But we're not going to worry about VPN segmentation right now. That'll be a video that we come up with down the road. When I create VPN1 and I enable an interface inside of VPN1 just by no shutting it and bringing it online, OMP by default will automatically advertise connected interfaces in that VPN. That means that I don't have to do anything other than turn that interface on both sides. So over here, good. Over here, good. Boom. Those routes have been advertised. Another way that this works is if I have let's say I have this link right here. Let's say this is a routed link of 10.1.61.0/24, just hypothetically speaking. If I want to reach this particular prefix and it's reachable off of the switch, I can actually create a static route on the vEdge in VPN1 to point to this particular prefix and switch 16 is my next hop. Perfect. Then I would also be able to advertise a static route and it would come across and be learned over here. So I would see a 10.1.61 via OMP, so on and so forth. I can also add in OSPF and BGP, and we'll take a look at exactly how that works as we proceed forward. So I actually want to demonstrate this to you so you guys can see exactly how this works. Because if you've never played with it before, it can become kind of daunting. We're going to do this with the CLI so you guys can see how this works. Because right now, none of the vEdges are templatized. I'm actually going to go through and I'll throw templates in later on, but right now I'm simply working on the CLI. So let's go ahead and dive into this config real quick and talk about these details. So what I'm going to do is on vEdge1, I'm going to take one of the interfaces, so gig 0/2, on all the devices, and I'm going to advertise those into, I'm just going to enable it globally. So I'm going to type in admin and admin, and I need to create a VPN. So if I type in VPN question mark, I can pretty much deploy anything I want on this box. So I can type in VPN1, for example. Now I've created a VRF, right? Now what I need to go do is I need to actually come in and specify what interface I'm going to work with or what service I'm going to turn on, things like that. In this case here, I'm going to type in interface GE 0/2. And I can go ahead and type an IP address of 10.1.16.1/24 and no shut it. Okay? Now on switch 16, since I'm right there, show IP interface brief. Okay, cool. It actually stayed put, so I'm happy about that. So what I'm going to do is on vEdge1, now that I've got that configured, I'm going to go ahead and I'm going to commit it. Okay, so now it's been configured and committed. So now if I do a show IP route, you'll see in here I have 10.1.16.0/24. It's connected, right? Now if I do a show OMP peers, what I'm doing is I'm actually sending routes from vEdge1 over to vSmart, right? That's what I'm doing here. I'm sending routes over to vSmart. If I go to vSmart and I log in and show OMP peers, I should be learning 2 routes in, right? If I come up here and show routes, I should be learning, where is it? Right here, 10.1.16/24. That's been learned, right? Now, what I need to do is, if I look at the show OMP peers, you'll notice that I'm not advertising. I'm not sending those routes to anybody else. So let's go ahead and change that. Let's go to vEdge3. Let's log into vEdge3. And we're going to go to, I think I typed in the password wrong. Admin. We're going to type in VPN1, and I'm going to specify interface GE 0/2 and IP address of 10.3.13.3 /24, no shut. And let me check on 13 real quick. Show IP interface brief. Perfect. So now what I get to go do, actually let me do show interface gig 0/0.1, no interface gig 0/0.1, interface gig 0/0, IP address of 10.3.13.13/24. Go ahead and say that real quick. So now what I'm going to go do is on VH3, I'm going to go ahead and I'm going to commit that config. We'll give it a couple of seconds, right? Come down here, do a show OMP peers. And you can see that I'm sending 2 routes and I've received 2 routes, right? So if I do that, we're going to go in here and say show OMP routes. And if I come down here, I don't really like the way that it breaks it down, but you know, it is what it is. So I'm advertising 10.3.13, and I've also learned 10.1.16. Now if I do a show IP route, you're going to see via OMP, I'm learning 10.1.16 via both, twice actually. And you're like, well, why am I seeing it twice? Well, I'm learning it from 2 different T-locks. What's a T-lock? A T-lock is a grouping of information to help determine where to send traffic. So a T-lock basically is a combination of the system IP, or basically the device that advertised the route to me. In this case here, it's VH1. I'm learning it from over the MPLS color and the public internet color, and the encapsulation for the communication between VH1 and VH3 for this communication is going to be IPsec. So it's going to be a site-to-site VPN. Is basically what it's going to be. And if you're not sure how to validate that, you can do a show IPsec outbound connections, and we're going to have connections to 12.1. You can see that I've got that going out MPLS, and I've got another one going out public internet. So I have two VPN sessions essentially. So what that basically allows me to do is then for any communication from gig 02 to from VH3 from R13, for example. So let's go over here and do show IP route. I do have a default gateway. Let me go check on switch 16 to see if I have a default gateway. Show IP route. I do not. Let me go ahead and create one. IP route to 10.1.16.1. Okay, so what I should be able to do, if I've done everything correctly, what you should see is I should be able to ping 10.3.13.13 and it should respond. It does. Now, you'll notice that when it did that, it paused, right? So if we go back to VH3 and we do a show outbound connections, right? We don't add an additional connection, but what we start doing is we start sending traffic back and forth over the VPN tunnel. What's happening here is the communication is actually being encrypted as we send the traffic. So if we do a trace route, the IP, and then the target is 10.3.13.13, source address, we don't care, numeric display, yes, and then do this, you're going to see it's going to leave, the next hop is 10.1.16.1, which is the inside interface of VH1 on gig 0/2, and notice the next hop is 10.3.13.3, which is the inside interface of VH3. What you don't see is any tunnel. There's no intermediary hops, right? So it's not 10.1.16.1 to 10.101 dot whatever. There's no DMVPN here. There's no GRE tunnel here. There's no IPsec VPN, VTI tunnel here. None of that exists. So it's straight up being punched over the transports from VH1 to VH3 and getting to where it's got to go. Now, if we jump back onto VH1 and we do a show IP route, I'll see 10.3.13 via both T-locks, which means I have equal cost multipathing to send the traffic across the wire. Fine by me, I don't care. Now, if we were to take VH4, for example, let's go ahead and add him to the party. admin, and an admin. Let's go to global config, VPN 1. And then we're going to type in interface GE 0/2, IP address of 10.4.15.4/24. No shut it. And then commit. And then take a look at R15. Show IP route. I have a default route in the routing table all ready to go. If I go back to vEdge 4 and I do a show OMP peers, I should be learning 4 routes. I've sent 2, right? So I'm gonna say, how is it sending 2? I don't get how it's sending 2. You've got 2 different egress points. You've got one going out MPLS and one going out public internet. Because you have 2, you're sending the route twice, one out each TLOC. That's why you see that. So you have that in play. We're going to do a show IP route. We should have a couple more OMP routes, right? We have 10.1.16 and 10.3.13, which is what we want to have. And we have 10.4.15. So now if I wanted to go back to router 15 and I wanted to ping 10.4.15. I'm sorry, in this case here it would be 10.1.16.16. I could do it. And if I wanted to ping 10.3.13.13, I could do that. So I have reachability over both connections, and they're both point-to-point tunnels, which means if I do a trace route to 10.3.13.13 numerically, I leave my default gateway of vEdge 4, and I'm piped immediately over to vEdge 3, and then to router 13. Now, if I was to add an additional VRF or a VPN tunnel, or I'm sorry, just a VPN in general, it would propagate, right? But if I wanted to communicate from, say for example, let's focus on vEdge 3 at the moment. If I wanted to go from router 13 on gig 0/2, send that traffic, or I'm sorry, gig 0/0. If I wanted to send that traffic out gig 0/2 on vEdge 3 and have that traffic come back in on, or go back out gig 0/3 and come in on gig 0/1 on router 13, it would not work because it's a VRF, right? 2 different routing tables. I'd have to allow traffic to go between the VPNs in order for that to work. I tested it out, it didn't work. Not that big of a deal. But normally you wouldn't want communication going between VPNs anyway. It's when you're trying to allow access to you can, don't get me wrong, you can allow VRF integration between each VRFs, or VPNs. That is 100% possible, but there's usually a reason for it. There's usually something you need to reach on a different VPN, and you allow routes from that particular VPN to be propagated into a different VPN. That's another separate table. That's a VPN segmentation. We'll take a look at that in a future video. But basically, this is what I have going on, right? Nothing crazy, but you'll also notice that for the connections that I have, I'm doing direct point-to-point. So I'm not trying to reach a loopback or a LAN segment on the routers behind the vEdges. I'm trying to reach the routers that are directly connected to the vEdge. So I'm just talking connectivity right now, and that's it. So if I wanted to take this up a notch and start actually doing static routing and use a static route on the vEdges to point to where the connections come in, could I do that? The answer is 100% yes, you can. Let's go ahead and take a look at doing that. So on vEdge 1, I have a loopback address on switch 16. If I show IP interface brief, the loopback address is 10.1.0.16, excuse me. So if I wanted to reach that, I go on vEdge 1, and if I wanted to ping it, 10.1.0.16, it's like I don't have a route in the routing table for that, so I'm going to go ahead and drop it. So how do I fix that? Actually, I'm sorry. Let me end that out. Let's ping VPN 1, 10.1.0.16. It says I don't know how to reach that. So what I can do is I go to global config and type in VPN 1, and I can type in IP route 10.1.0.0/24 via 10.1.16.16. Okay, I'm going to go ahead and commit that. And then if I look at the show OMP peers, I've advertised another route. And if I look at vEdge 3 and I do a show OMP peers, I've learned more routes in. If I do a show IP route, I should see 10.1.1.0 coming through from router 1. Okay, awesome. So now if I go back to vEdge 1 and I hit that up arrow again, I try to do the ping, it'll respond no problem because now it knows how to reach it. Let's do the same thing on vEdge 3. Let's go to global config, VPN 1, IP route to 10.3.130.0/24 via 10.3.13.13. If we look over here on vEdge 1 and show IP route, we should see a 10.3.130 right there. So we know the routes are coming across the board, which is what we want to see. Now if I go to switch 16 and I try to ping 10.3.130.13, I can ping it. Now I'm pinging off the 10.1.16.16. If I try to ping, let's hit the up arrow and source it from loopback 0, I'll also be able to reach that because I have static routes enabled on vEdge 3 to get back to it. In other words, on vEdge 3, I'm pointing a static route to get to the next, to get to the prefix of 10.3.130, go to the next hop of 10.3.13.13, and that's basically how that process comes into play. That's some basic connected and static routing. Not terribly complicated, obviously, but it's one of those things where you really have to understand what's going on. So what's cool about this is I can scale this, right? I can scale this quite a bit, and I'm always going to have multiple egress points, right? I'm going to have MPLS, I'm going to have internet, and I'm going to be in great shape. So when it comes to stuff like that, this is where the power of SD-WAN comes into play, where I can quickly scale my network, and I'm relying on a routing protocol to do it. I'm not going to have overhead with, well, there is IPsec overhead, but I'm not going to have overhead with DMBPN and GRE tunnels and EIGRP. I'm relying on one protocol, OMP, and then the IPsec data plane encryption that it comes with it. So that's basically how that comes into play. So beyond that, let's go ahead and get the rest of these devices up and running. Actually, you know what? I'm going to leave it where it's at because I feel like that's a good spot for it. And what I'm going to do as we progress is I will take a look at getting the connectivity up and running with OSPF and dynamic routing, and we'll see exactly how that comes into play. So we went ahead and we got dynamic routing, or so I should say we advertised connected routes, and we talked about how the VRF comes into play because that's what we're basically doing. We created a VRF on the inside. Because if we were to look on vEdge 1, right, and let's look at this, you can see that inside of VPN 0, if we do a show IP route, VPN 0, what do we see? We only see the WAN facing connections, right? Right, that's all we see. We don't see anything else. If we do a show run VPN 1, we only see what routes we've learned via OMP. OMP is propagating traffic from router 3 and from traffic from router 4, and that's how we're learning these prefixes. And that's exactly, that's fine. That's exactly what we're looking for it to do, because at the end of the day, that's what the SD-WAN solution is supposed to do. It's supposed to take routes from other locations and be able to send them to us securely via OMP so we can learn them. It's not being routed via OMP. OMP is just a control plane that allows the routes of one site to be advertised to another site or multiple sites and for them to learn it. But remember, none of the control plane isn't connected between the vEdges. It's vEdge to vSmart and then vSmart down to vEdge. So if we look at the vSmart and we look at the show OMP peers, we're learning a number of routes, right? If we look here, we see 4 received routes from 3, because that means that, again, for every prefix that we send, we're actually sending it out both transports. So therefore, we're going to see duplicates of each route. If we were to do, and you'll notice that in here, there is no installed, right? Because all the vSmart is doing is hosting the control plane. It receives OMP updates in from the vEdges and simply redirects them or reflects them back down to the other vEdges that haven't received them. And that's what allows the power of this solution to come into play, is the ability of propagating the routing information. So basically the vSmart is basically a gigantic BGP route reflector. and that's basically how it works. So with that being said, we're in pretty good shape at this point. We can take a look at doing the OSPF and getting BGP working internally, but I do want to begin taking a look at flipping over to templates, because templates by themselves are really where the power of SD-WAN comes into play. So that's basically where we're gonna, at this point in time, the static routes and the connected routes I can have working I can actually transition the current devices that we have working as it is right now. I can transition over to templates relatively easily. If I switch over to dynamic routing with OSPF or BGP, or add multicast or DHCP, VRRP, anything other than NAT, that's going to require additional configuration steps, but we'll talk about those when we get there. So right now, we're in good shape. I still have to get the connections for the switches up and running. I still have to get the ASA configured, and I'll show you guys how that works when it comes to like doing internet breakout and providing NAT at the V edges for local internet breakout and things like that. So until next time, guys, thanks so much for stopping by and hanging out with me in this video, and I'll talk to you guys in the next video.